All right, everyone, we're back for some more streaming live development for Godot. I am going to be going over some of the stuff that I was talking through last time. Managed to get through the perk selection menu, and I'm going to go ahead and show that off. I'm also going to be working on tonight. I've got building a set of custom lobby information using Nakama's servers. Go ahead and show off what we got from last time. Managed to build the whole perk menu out. So now when you go into a character, let's go ahead and create or grab one of these existing guys. You'll get access to the hero upgrade menu. There will be a number of perks on your equipped section, and then a number on the stored section. So eventually, this system is going to have more upgrade choices for like the armory and the buttons up top. But for right now, you'll just be able to swap these perks out. And so when you level up in a match, it will randomly select, draw a number of cards from your perk deck as it is, and you'll be able to pick one of those. So you see that I can equip up to 20 right now. You go ahead and just move a bunch over. We'll just go through real quick. You click on them. They've got, give you a little tooltip of what they do. You can cancel the move. You can only have 20, so you cap out. It will tell you there's no slots available. Also built all these perks and hooked up the weapons with them, so they'll actually apply correct bonuses. So let me go ahead and move this guy over and grab that Hammer Mastery 3. And so you can back out this menu. If you hit the back, you'll be able to it'll move you to the save and close. You can try to back out without saving it. And that will, raise all the progress, but it will only save your progress in this menu when you hit save and close. So I can go ahead and take a look. Let's just go to the sandbox here. It's going to be the easiest way to show off what we've got. Create a solo mission here. And I put a bunch of treasure chests in this map because those populate a lot of these orbs, which are where you get to the experience that you see growing in the upper right. And so, yeah, you have access to these things. It'll redraw 3 cards or 3 perks every time you click one of these, so you can't just open and close the menu. So if I were to, increase my max stamina, you see my stamina bar goes up, increase my health bar goes up. All those health and stamina, actually the health at least is networked across, so you'll be able to see their players' health increase as well because they'll have their own bars. So, just looking at the weapon damage, my standard is 35. I think if I can find one of these Axe Mastery, it says increased by 5%. And yeah, I'm doing a little bit extra damage with this thing. I've also broken the attacks up, so this lunging attack, you'll see in game you can do these dash dodges, and at the end of a dash dodge you can combo with an attack, and that's called a dash attack. So you can modify them specifically with that lunging strike dash attack damage, so this should do more damage. 31 now. So yeah, that's basically all there is to that system. Again, I want to build it out. Eventually these stat bonus versions of perks are going to be the least complex portion of the perks. We're going to do dashes and dodges that do, dropping bombs, do damage on hit, things like that. But these are mostly just stat buffs. And so you'll be able to customize your character out of each round and have that level up experience every time you play in a semi-random fashion. So you'll be able to set your build. Cool. So yeah, that's all there. Let's get out of here. And so what I wanted to show off a couple of things before I dive into the new stuff I'm working tonight. And there's just kind of some pointers in case people are looking to optimize stuff in Godot. I've got quite a few times I've worked on this thing so far where I've worked on different optimizations using the physics for Godot's physics and using dot trace to track down where my hiccups are, because a lot of the stuff they don't tell you out of the box in Godot. You can find little optimizations for things. So when my games effectively got you know, up to about 100 monsters on screen at a time. They've all got their own AIs, they've all got animation, they've all got physics movement, and it's got to be able to support that many characters without slowing down too much. So I want to real quickly just show you an optimization I did for it. The first thing I'm going to do is I'm going to open up my survival mode, and I'll just change some variables on this thing so I can show you what it looks like with a lot of characters on screen at once. Survival. Survival mission. And so this is just a mission that would spawn waves of monsters over time. So I'm just going to quickly go ahead and speed this thing up so we can get a lot of guys out here pretty quick. I think the quickest way would probably be do... Where's the timer on this thing? Spawn rate. So we'll spawn them every 3 seconds. We'll increase the waves. And we'll just show you real quickly how many monsters I can get on screen. And I'll open up the debugger here. You can take a look at where my profile sits at for these. So the main thing I want to talk about with this is getting the physics process to be able to run with a lot of characters. All the work I've done to optimize involves doing shape query checks before you do physics moves. I'll show you what this looks like. So right now I'll show you what it looks like when we kind of where my upper bounds are in terms of performance. I'll just play a solo version of this thing and just keep an eye on the FPS and specifically the physics process. I'll get a bunch of guys on screen here pretty quickly. And I've got it caps out and it'll cap out at 100, so it won't spawn more than 100 monsters. But I expect to spawn 100 monsters maximum. Usually if you're in that state in the real game, you're going to be in a lot of trouble. So 100 monsters and then up to 4 players. So you notice that I've got some tech involved where the monsters space out from each other. They are not colliding. I'm using a component type I built called a flocking component that will push these guys kind of slowly away. In fact, the physics of the character is the same thing. I can push up against these monsters and we kind of squish away from each other. It makes the movement a little more fluid. Also means that when I do attacks that push me into into monsters, it kind of bounces off them or pushes them back, which is kind of a neat effect. The only thing that turns off the flocking that I've got for that component is when I dodge roll. The dodge roll, you'll see me dodge roll past people, and I can get past their push effect. So you see, I've got a bunch of monsters on the screen so far. Now they're turning on and off, but if you look, even with this number on the screen, we're hitting a physics process of 3 milliseconds, 2-3 milliseconds at a given time. Let's just cap out real quick. And we're still at 100 FPS. We could do better on the FPS. I'm sure that most of that's coming from the process, not the physics process. And they're spawning things that are not just monsters. They're spawning all these projectiles. Lights are calculated in here. So yeah, so this is kind of what you'd expect with the performance stuff. It was not this clean or performant when we first started this. And I can show you the real quick fix that made things a hell of a lot more performant initially. I'll go through that real quick. So yeah, about 4 milliseconds. And that includes me being pushed and damaged and everything like that. So, I'm going to go ahead and show what it looks like when I turn off this performance switch. So I'll give you an idea what it looks like in the creature, which is my base class for all the monsters and the heroes. There is, instead of doing the typical move and slide event, for your movement, go ahead and find this guy. Well, I think I might have put it into the monster. Let me take a look. Yeah. So there's a function I overrid called move creature. Now what this does, It does a couple of things in here, like it will get the flock direction based on the flocking component to kind of figure out where it's going to move to, but the key component here is instead of calling move and slide and passing in these parameters, it actually does a check beforehand. It checks to see if the foot is colliding, and what I mean by foot is the physical space. It's a circle right now that determines where the creature is standing at any given time, and I run this check called foot collides at point. And I'll just show you what that looks like right here. Same creature. So, I have a foot collider component I built, and it does a chest check on it. And I'll show you what that looks like. Okay. So the creature itself has this foot. And this foot is just a collision-shaped 2D that sits on the creature. I'll show you what the scene component looks like. In Godot here. So here it is. It's a foot collider. It's got it says it's a capsule shape here. I'm not sure if I use a capsule shape. It looks like I do. Looks like I do in the overlook right here. Couple of things it does is, first thing, it caches the world state, or the world, and it also caches the space state. One of the things you'll notice if you do any kind of query checks to the physics server, having to re-grab those elements, at least from what I saw in .trace, they're more expensive than they need to be. So if you grab them ahead of time, or you cache them somehow, right now they're cached in the first tick of physics process on this because they couldn't do it unready. I was actually getting these creatures spawning before the physics server was spun up and having some issues there, but I expect they'll be moved out to an activation function or something. So what I also do is I actually cache a bunch of shapes, and I made a dictionary list of these shapes that I use. So whenever it does a check, it determines the size of the shape, and it's going to have to use a shape to cast with. And I'll show you what that looks like as well. And certain monsters have different shapes. There's obviously the rotation of the foot because it's a capsule, similar to what you see in the Godot file here. There is a rotated 90 degrees. There's some position data as well. And we'll take a look. So I run a query. Actually, I set up the query parameters because it's another thing. This query parameters struct that is used for those queries also doesn't need to be filled every time. If you can cache that out and just reuse the query params, you're not having to update it every frame or every time you do one of those casts. Again, every time you do something on the physics thread, it's going to cost you, more than you would expect because the thread is running at a fixed rate. You don't necessarily want to do anything on that thread, at least the way that I've been running it. Anything on the thread except for doing the checks for intersecting shapes, moving and sliding creatures. So as much as you can get off that thread, the better. And here's the actual function. I'm doing a intersect shape check with a query parameters. All I'm just looking for is, I believe it's just one result, and that means that the foot location that you'll be casting to, or you're checking forward towards, is going to hit something. So let me just give you just a look at that again here. You can see under move creature, I'm actually determining how much further forward I would be moving. So say I'm going left, it's going to check from my current position, it's going to find my foot, and it's going to check my movement direction times the delta speed. And that's where the physics step will actually move me when it does a move and slide. And so I'm actually casting forward as long as your creature that you're moving isn't moving so fast that it could miss. And my creatures are all capped at a reasonable speed, so this will never happen for this particular check. Anything that moves faster than that, I've got different functions to run. So instead of calling move and slide, it will only move and slide if it checks the point. If it doesn't have anything at the point, it'll just move it to the position and set its velocity. So the best you can do is try to avoid this call, the move and slide call, as frequently as you can. So this means that whenever a creature's moving out in the open, he will just move to position. And whenever he would potentially hit something, I actually have to call the move and slide to get him to move to that to the correct position after sliding. So I'm going to show you what it looks like, the perk of it when I turn this off, and we actually just call move and slide with everybody. So we'll just do this. Comment these out. And we'll take a look at 100 creatures. Cool. And we'll run it. I'll get that debugger monitor open. We can take a look at what the physics are doing now. Okay, so everybody, even if they don't need to, are going to be sliding around with move and slide. You can see we're up to nearly 2 with just the creatures I've got on the screen, and that's probably 15, 20. And so it'll start building up because no matter whether or not they need to actually slide against somebody, they're still calling the physics check to slide and determine if they're going to collide with anything. And we've basically what we've done is we've skipped that step. We handled it manually. We called the check ourselves, and as long as that check passes, we just move the creature. And so we're up to 5, and you'll start seeing, I mean, we've still got a multi-threaded physics server, but we've got a lot of things that use it. So like every projectile is going to be doing shape query checks. Okay, we're getting closer to 6. Now, obviously, the benefits of this system when you've got more closed-in rooms is going to be less. Like, the more people who are actually going to be rubbing up against walls, any kind of obstructions you've got in the room, the more of that you see is going to cause more and more problems as it goes. So there is definitely a trade-off here with open rooms versus closed spaces. So there I'm at I don't know if we're at 100 now, but it's pretty close. But effectively, we've shaved, 4 or 5 milliseconds off of the physics process by just pre-calculating whether or not the person is within a location where he could potentially hit a wall versus just letting the physics handle it and determine if there's a wall there. And there's a whole bunch of things that I recommend everybody who's building a game that has any kind of even games that don't use a whole lot of physics. Like this game doesn't use a whole lot of physics. Just keeping as much of your logic off of that physics thread as you can, because you'll want that for collisions and things like that. I've got fairly. Let me take a look at. I'll show you what one of my weapons does here. Go grab one of the, I think it's the bow that does the. So this bow has 2 kinds of projectiles, and both of them need different cast types. This one fires 5 arrows, and this one is a ray cast. If I can get it to go off with all these guys in my way. This one's a ray cast projectile. So both those things are obviously using the physics thread, and we just want to make sure that those calculations don't have it go through the wall or anything weird like that. But it's holding up actually pretty well without that optimization, but you can tell the optimization is definitely beneficial. All right, let's clear out of here. Bring this back. Okay, so that's what I worked on the perk system last time. So what I'm doing tonight is actually working with how Nakama handles its matchmaking system, or more like the custom matches. So my game is all networked. All the gameplay effects are networked. I'll go ahead and open up 2 clients here. You can take a look. The way it's done is it's using a Nakama listen server to connect 2 peers. So, and then the Godot's high-level networking kind of handles all of the major events. But I built a couple of custom things into it to make sure that it is a little more robust than just using their standard event systems. And I can go through that at a later date. But so the big thing is I've got I can create an online match. I'm gonna go ahead and like pick. We'll go with survival because we just did that. So I've got a lobby system. Players can join up. You can see that in here you'll be able to check the lobbies and figure out whose lobbies whose lobbies these are. More information like who's in the lobby, the username of the lobby owner. So you can join up to the lobby, and then it'll populate the lobby's information with your player information. So let me leave this lobby as this guy. You can see, you can refresh this thing with this refreshes it. But I could go back. I can go ahead and let's make a new character. Customize the character a little bit. We'll go ahead and we'll use this guy. He can go find the game and he'll join up. Come on, connect. And then he's in. It'll populate his character's avatar information as well as his like the player name. Now you won't be able to see it here because this is pretty temp stuff. But my mission tonight was to get started on using Nakama's multiplayer connections to kind of seed the server with more information. Now, the way Nakama sets up its non-authoritative servers, which is basically the one we're using, all it brings with it is a match ID and then a match owner, I believe. I think there's maybe one other thing, but it doesn't carry information like you would expect on like a server or lobby that would have, what game they're playing, all the other information you would expect, who's in the match. It actually cannot handle it on its own. So in order to get around that and be able to provide more information, I actually built a couple of custom functions on my Nakama server. And, let me find that file here. Oh, yeah. Okay, so there we go. Open this guy up in Notepad++. Okay, so the Nakama server that I've set up on through Docker allows you to add custom Lua logic to your server. And these are essentially function calls you can call from anything that's connected to your server. So I built a system that allows me to store an array of custom matches. And I'm calling them custom matches because they're basically going to be the containers for all of the stuff I want other people to be able to query and see about the current matches on the server. So you can see I've got custom matches. If you look, a custom match has all of this data. And I'm going to be able to send a payload of data, which in this case is going to be a JSON blob of data. And then I'm going to insert that custom match with the new data in here. And the big thing is that you can query by match ID whenever that's the one thing that every Nakama session, or I forget what they call it, Nakama match has, is this match ID thing. And so you can query the match ID, query the custom matches by the match ID. So that's how you start getting information about all the custom matches on the server. So yeah, so I've got this custom helper here called get custom match by ID. That's the big one to figure out where it's connecting. That's essentially what I'm using now, but I'm not really using any of this other payload information, not sending it up. So what I want to do is I want to be able to like send the username up, and maybe information about. Well, let's do username and player count. I don't really care about the other ones now. We can always fill those out. Unfortunately, I don't really do much with the user IDs right now. Every player is given a name, but it's like a random generated number with a name. But I think it'll be fine for now. And maybe we'll update the mission type. So if you look at my setup here, every one of these online games is technically a thing called a match. And those matches contain the current mission. And the missions, in theory, can change before they're launched. So you can see people go into the lobby, and when they're in the lobby, they can change the current mission they're looking at. But yeah, let's go into where I actually send this information up. Now, the Nakama part of this, let me go look at the Nakama AP, is stuff I got from Snowpeck Games. He's got a pretty great tutorial on how to set up the server for that, and he's got a pretty cool API he built for Godot. Unfortunately, he built all of his Nakama stuff in Godot script, and all of my stuff that needs to talk to it is in Mono. So I have built a thing called the Nakama broker, which is kind of my back and forth between his API in Godot script and the Mono that I'm working in. So I'll show you real quickly how that works here. Open up my local file. This is my network manager file called Nakama Network. Okay. So what I've done for this, and the way that Godot script and C# can kind of talk to each other, is just by sending signals to each other. And you'll see that I've got a bunch of things that connect his callbacks that will be sent back to the script, and I have a lot of calls that will be sent to his scripts. And so these two will talk to each other basically through that bridge. So right now, the thing that I use in order to create a match is this guy, create match. And I do some heavy printing on this because it does get a little confusing. And this calls a function into the Nakama broker called create match. And I'll go ahead and open that guy up in Godot here. So it'll call this function. And this function will essentially do a handful of things. It'll connect it back to the session, make sure it's valid. It'll actually connect to it by device, as that's the kind of authentication that Nakama uses. And then if it opens up a socket if one doesn't exist. And then it sets these variables in online match. And then he calls create match. So this is created in online match. I can go ahead and look at where this is created, because this is actually where I start creating custom information. So he has create match up here somewhere. Let's do this. Okay. He's got create match, and then he's got this callback called on match creator. All this does is it creates the standard Nakama match, the one that just has the match ID, without any good information. And I want to be able to send better information up to it. So he's also sending, the only data that it sends is this data, which is the return of if the match has been created. The match has been created asynchronously. So and this is what happens if it can't create a match. So this is the callback for when it's done. And in here is actually where I start doing my stuff. I start doing this. I go create custom match, and at the bottom of his stuff, I went ahead and built these functions. Create custom match, which is the the way that I talk to the Nakama server to tell it to run this custom event. And that's this guy, create custom match. If you look over back at the Lua, you can say that create custom match, and I'm sending that payload up. Now, so what I need to do is I need to make sure that that payload I just send up is actually containing good data. And the real question is, where do I want to store that data? Because all this is a bunk string, not useful at the moment. Lobby name, test name. What I could do on online match, I think we set a bunch of variables when we create our match. So this guy, see, online match max players, online match client version dev, tells you the servers it's using for the relay. Why don't we go ahead and add a couple more variables for online match, like our player name. And that way we'll have it over here. And then I want to set it, so let's go back to the... So the weird thing is we don't actually call create... Actually, you know what? It might be better to send the JSON blob right through here, since the broker actually gives us all the information we need. And that will work. It should probably not be the blob. It should actually be just a dictionary, right? Yeah. Let's send dictionary through here. And we can go I forget the call for. Does it just do this? Let's see, what does it actually do to get dictionary information? To dictionary. Session ID. It looks like it's just taking a key and setting a value, which is weird. And that's just a dictionary, yeah. So it's just this inside the brackets. But how do I get the value out of the dictionary? That's the big question. Yeah, players key. Custom match list payload. It's got to be the string. It's got to be a string inside there. That's why it doesn't like it. Come on. Okay, cool. So now I'm gonna go just make sure that my player name gets pushed through. So now I've got online match, and go to our create custom game, and now we want to go, what's our username? It'll be player name. And that should now send it up to the server, and that way when we pull it down again, we'll be able to figure out what it is. I'm going to go ahead and just quickly create that variable in my C#. Create match. Let's do collections, dictionary. can get the, I don't know if I call the player name, is it variable, if I just use the name of the class itself, or the node itself. I think I might make an actual player name. Load game data, player name. Okay, so I do hold that data, so I want to do this first, although I'm not sure that player name gets populated. Just for safety, let's do it this way. Let's call it Steve for now. And we'll figure out the rest of that, and then call create match, and I can send information with this call now. Send dictionary. And now that there's a parameter there, this thing should have that parameter and should be setting the player name. Okay. And this will send it to the server, so we'll have the correct information on the server. Now I want to just kind of close the loop, make sure I can grab the information down. So the call I make to get the match list is this guy. Actually, I've got custom match created, which should bring me the data. So let's do that. Custom match created. Yep. So this is the match info. So let's see if the match info brings me back my player name. I'll go ahead and do. So it's Steve. It should be Steve. We'll figure that out pretty quickly. All right. Play, and then we can go ahead and create an online match, and then here we go. We've got not gonna clear some test lobby, test name, player account. Here we go. Username Steve. So it did the full loop. It gave us the correct name. And now I want to build to, when other people pull for the custom lobby information, they can actually grab this name to know whose lobby it is. And we'll probably send more and more information across to that, to the server version. Like, I want to be able to change the kind of mission that they're on, and because they'll be able to change it in here. Come on, buddy. Weird. Okay, so I like that. Let me go ahead and look at the Lua again, and we can go ahead and start adding some stuff to it. We want to probably add some new information here. So we don't really care too much about user ID. I do like the username. I do like player count. But let's create another one called, we'll call it mission name. And then we want to do something like adding players to the match. I don't think we call that yet. We should. This is where you grab the info list. I don't think we need the lobby name. So we've got the username and the mission name. And I want to be able to actually update the custom match with a new mission name. It'll probably just be a single thing to run. And I've got to, in order to make this work, I believe I have to reconnect it, I have to repost it to the Nakama server, to restart the server. Okay, so we want to decode the payload. The payload might just be a string in this one because we just want to change the mission name, but let's just make it a full payload, JSON payload. And now we have local mission name. Oh, and I do want to actually grab the, because I actually want to grab the custom match. Because I need to get a correct custom match, or this is not going to find the right one to update the payload. So now I have the custom match. And then all I need to do is get this custom match info and then set its mission name to my new payload mission name. Let's grab this guy. Okay, so that should update the custom match mission. And we'll go ahead and update this guy because I want to get the match ID and username and mission name all set up in here. I probably should update the number. Oh no, so we gotta add player, so we actually get information here. And all this is doing is adding the player count, so it's going to modify player count, so that number, which is fine. We'll start with that. And if I recall correctly, I've got to modify my server by doing a Docker command. Let's see. Okay, I think what I want to do is I want to do it's either a push or it's a create. Let me see. Let's see what push does. Let me kill it actually. Kill. So now my Docker's not running anymore. I think it might be build, because I think it does compile these things. Huh. It says create and start containers. Let's see if that will give me my Lua script in here. This looks pretty close. Let's see if we can find it. Nakama data modules. Initializing the Lua. Runtime module started. I don't see my Lua file name. Let me take a look at the Docker. Okay, so it's started. There it is. How do I see? So it started up. I see these RPC functions. Okay, so it did. It registers these RPC functions. Create custom match. Get custom match by ID. Clear dead matches. Remove player. But I don't see the way to modify it. Let me just look a little. Can you make this thing any wider? Okay. Okay, we got destroy, custom, add, remove, custom match, create custom match. Yeah, I don't see the new function in here. Not save it. Let's take a look. Oh, I have to register it over here. That's what's going on. Totally forgot this section. So this one's called Update Custom Match Mission. Custom match mission, and we'll just use the same one because that seems to be what we've been doing for the previous ones. And then let's go give it another shot. Update custom match mission, so it's there. Okay, so that's the new Lua script is running in there. So we know that the server's got all the functions we need now. Okay, now that I'm bringing down the information, I've got custom match created, and I want to do some updates to the UI. So I'm getting this information. I probably need to bind something to grab this match info. I mean, I could bind directly to that match created and grab it off of there, but I don't know if that's the smartest thing to do. Let me see. Let's take a look at the match select menu. What I want to do is I want to grab these entries and these entries. Let me open this guy up. So this panel has the missions and then it has the lobbies. We're going to show you the lobbies. Just want to figure out the lobby. It's the lobbies panel. What populates these things? It's got to be a scene I built. Lobby player info? Nope. take a look. Well, I can actually figure it out just by opening up the engine and running it. Yep. Typically, Godot Mono will crash every now and then on startup for no apparent reason. Seems to do it whether you're running it from a play or you're running it from the editor, so it doesn't have any kind of logic to it. I don't know if the regular Godot is that crashy, but it seems to happen quite a bit for me. All right, so I've got this new one. I'm going to go ahead and create the online match. He'll be in the match, and then over on the other side here, I'll go ahead and look for it. I just want to take a look at what that slot looks like. See this guy. I am populating something here. I get the Steve name off of it. So Steve, one out of 4 in there. And what is this thing called? Open up the remote. Menu, match select, missions, lobbies panel, open lobby scroll. Come on, online match info button. So this is what I'm spawning. Great, that's exactly what I want. So that's this guy. Okay, so now he's got to figure out what connection this data, where the data for this guy is set, and what these fields, each one of these fields mean. Update them. Update that 1 out of 4 when you get more players. Because I suspect that doesn't do anything right now. Let me double check. I'm gonna go ahead and run this another Godot over here. Find Steve, go into his match, and then refresh it over here. See, the number isn't refreshing. The player count isn't refreshing. So I'm not adding players correctly. And then we can join it. Now we're all in the same lobby. So, okay. And we all go in. We've got the remote on, which is why it's making me lag. There we go. Okay, so everything gets him in. They're just that number is not. So I've got a lot of state replication variables printing out here. So let me go ahead and turn those off so it's a little easier to read. But for sure, it's not giving me. It's not updating the player counts. Packet sender. All of my my networking stuff is in 2 files: the packet sender and packet receiver. So all of my basically, if I ever need to, I've tried a number of different networking methods. So this one, building it this way makes it a lot easier to switch them over to other stuff. If I wanted to like move over to Steam's networking or something else, even something custom. But this Nakama relay thing is working out perfectly fine for what I need. So I'm unlikely to change it now. But if anybody has any questions about how I do the state replication or some of the larger levels, I can definitely dig into how that stuff works. Let's see. So all I have, I've got logging messages on these guys. Turn them off. All right, let's go take a look at this thing. So this is the lobby name. We're no longer passing a lobby name, and this probably has a script attached. Yep, we got a script. Online match info. it is getting data set on it, probably when it populates, as opposed to listening. So let's go figure out where it's getting called from. It's getting called from the match select menu. So match select menu gets the online matches, changes the blob of match infos, which is exactly what we need. And I bet you I set this up as a struct, isn't it? No, it's a class, but it's just a dictionary. Okay. And here are all the variables that it will populate when it gets sent down. So I've gotten rid of lobby name. No, I've gotten rid of user ID. I'll change this to mission name. Of course, I closed it. I'll just keep it on this side over here. Take a look. Alright. We call it mission name. So now I've got a mission name, and so this guy, I want to figure out if I've got a mission name. I want to rename you. Now, one of the other things I want to do is support late joins and rejoins. Right now, I actually do a pretty good job of that. I just don't have any like specific logic about how to rejoin, but all the state stuff seems to work pretty well when I leave the lobby and come back in, and when I leave a match and come back in. So players can join matches right in progress. They don't have to go through a lobby system. Let's call this one username. We'll call it it should just be called the lobby owner or the mission over. It's actually the match owner. Match owner label, and then we got a player account label. Okay. I think for most of my themes, I end up using this one I built for the menu, for the main menu. It's called New Game Menu. And that gives me the pixel text that I like. Okay, so I've got these guys, owner name text, match info, username, we'll call it. That's called owner name. Where does this get filled in is the real question. So it creates a new match info and adds into this list using the dictionary. So it's a constructor. Yep. And it takes the dictionary. So, and that's the player count, which means the player count's coming in with 1 every time. So I suspect the Lua is not adding players when they join. create custom match, and we probably need, because we've got this, add player to custom match. I bet I don't call that anywhere. So what I want to do is I want to find the server owner and have him report when a new player joins and update the players in the custom match. So here's the Nakama broker. I need to make a new function on here. I suppose I could just call it in here. I think I've built it. Add player to custom match. I don't think I'm using it. So this needs to be done from the server owner of a match when he detects a new player joining, which is in the Nakama broker, or it could be in the player manager for all I know. Nakama network, and let's take a look. All these callbacks for players connecting. So we've got join match. I think the big one is when the player state change, or the player's online status changes. That's when stuff is pretty noticeable. So this is and then player left is also pretty important. Let's take a look. So we've got player status changed if the host is connected to the local peer. So this is what happens when a player status changes, it gets broadcast to every player on the peer-to-peer network. And this is telling me that whoever's connected, this is when you're connected, your local peer is not is the host of the server. This is when you connect with the host. And this is when a peer has joined. What we need to find out is if when a peer has joined and you were the server, we need to be able to update the custom match. So I'm kind of confused here. This new network tree, host is connected to the local peer. So let's try this. Let's just see if at this point, I think that he's getting called. Let me see the references for this. So in the match manager, on connect to the match host. This is when you were connected to a host. Oh, it's an or statement. Okay, so this is when you connect to the host. So that's fine. But if you are the host, then you need to know when peers connect. So what we need to find out is another check. We need to do if peer ID is 1, which means you're the host. Which my peer ID is 1. Which means I'm the host. And the peer that connected is not the same as me. Let's see. Let's rename this. Okay. And the connected peer ID is not equal to. Okay, and then so I'm the server, and I want to go ahead and call add. What was this thing called? It was called add player to custom match. Let me just double check it in the Godot. Add player to custom match, and I've got to be able to send the match ID up and the player that came. So I need to get the player username and session ID. How do I grab that player? That's a good question. I don't know how to grab that player. I'm sure there's a way I can grab that player for when he comes in, because I've got this status change. So yeah, this should have that's the peer ID. That's the status. Dictionary is the player. So I have all the information about the player here. So let's go ahead and just send that back. And what's the other thing I needed? I needed the match ID. Yeah, I need a match ID and the player. My match ID is just a big string. And I believe I cached that somewhere. I guess I don't. Okay. So when I'm connected to a match or I create a match, I want to be able to cache the match ID. So I will just quickly make a string. We'll call it current match ID. And so when I'm creating the match, I wait for these callbacks, and I eventually get the match ID. Match created. And I can do this. Match ID is match ID. As a string. And then custom match created is basically the same thing. That's when I get the custom match information. That's the match info, and then I want to turn that into a dictionary. I want to turn that into a dictionary. And hopefully that comes in fine. I can't imagine what would be wrong here. So match ID, username and mission name, and player count. Let's look again at the match info. Where did I put that? Here we go, match info. the username, which is essentially the owner name. Over here, we read the username. We get the owner name. Set the text of the owner name label. And tries to join the match with match info. Cool. And let's do this. Let's actually set up, we'll call it match ID. And that'll be, we can actually print out the match ID right on the thingy. Okay, we'll set that one up to be, it's gonna be a very long string, so let's move the mission name label up a little bit. Match ID label, move it down a little bit. Go from there. Let's see where we're at. I'm gonna go ahead and run this guy. Create an online match. Let's go find that match. Okay, so we've got that string. Let me run another one of these guys and connect one. See if we can get the player to update. Refresh. That's still coming with player count 1. And he should be sending that call out. So figure out what's going on there. Let me reconnect. Nope. It's not getting that player count update. It's probably something I'm doing on the connection side. Let's take a look at where this was. We've got... Oh, was I calling Nakama Broker and not calling this? Probably. I was not calling online match. Which I don't know if I actually... I don't know if I bind to that. But I could. Okay, so where is that thingy where I update, add player to custom match, Nakama Broker call. I want to do online match call. Player, and then match, current match ID. See if that does anything. Got a couple of these. Now, ever since Godot 3.5, the fact that you don't get a console unless you specifically open one with a console is a little annoying, considering how useful I find the console. Okay, final on games, still didn't update it. I'm gonna do a print. We're gonna print one of these things out. Add player to custom match. So the section has the session to be active. Match ID, user ID. So I'm sending the player. And I forget what the print statement in here is, just print. Let's just print the payload. Okay. Oh, can I just print the whole payload? I guess I can. Oh, I'm doing playload. Wait. Okay, I'll run it, but this guy's going to be the server because that's the only way I can get that thing to print. Create an online match. Okay, I am the owner. Hit run. Play. Find online game. When I connect, it should hit that. Should print that statement down here. Yeah, so it does print. It printed the user ID and the match ID. So user ID and then a username, which is a very strange username. That's the session ID. User ID is the session ID. Okay, maybe I did need a user ID as opposed to just the username, because that might actually come in handy as a unique identifier. Let me go ahead and add that back. So it did get it. I'm just not sure if let me go add that user ID real quick before I forget. Because that's actually, I mean, it really is the player session ID. And the username is something else. Because that's the player designated username. That's clearly something that comes from the server. On the Nakama side. But let me see if I can get that player count to go up. No, still one. Actually, let me run it again. I want to see if I'll print another statement or not. So it looks like it did print another. That's a player status change. That's not whatever this is. Weird. So another player status change occurred. But it didn't hit this add player again. It's possible where I put that is not in the right spot. But I'm going to look into this because the add player to custom match should be getting called. And the match info, is it? Match info is not null. Get the match by ID. The trouble is you really can't, as far as I'm aware, you can't breakpoint into the Lua on the Nakama server. I'm sure there's a way to do it. Maybe I have to look into that. But I think that'll be the next thing I'm working on, is getting that hooked up. Okay, I think we're about an hour in. I'm gonna go ahead and shut it down now. If anybody has any questions over what I'm working on and wants to know a little bit more, feel free to write them in the comments. I can definitely get to them. I'll see you guys next time.